Hi guys, welcome back to another video. So this video is a part of the series Deep Learning in which we'll be learning the concepts of deep learning right from the basics to code implementation. Okay, let's step into it. First, what is deep learning? Deep learning is a subset of machine learning, comes under the field of artificial intelligence, which uses models to learn and understand uh, predictions and the patterns, so the major relationship between input and output data. Okay. So yes, how deep learning is different from machine learning. So how it differs from machine learning. That's the major question. Uh, so machine learning uses models. Also, deep learning uses the similar models, but machine learning just uses algorithms to learn the patterns. But here in deep learning, we use neural networks to understand and learn the patterns and relationships. So, what is a neural network? Let's get into it. A neural network consists of layers. First, the basic unit of neural network is nodes. Here we can see that input layer consists of four nodes and hidden layer consists of five nodes for each of the both layers, and output layer consists of four nodes, right? So the function of this node is to receive input, perform computations assigned, and to produce output. So the output of the output from input layer is passed to the hidden layer through the edge, the link which connects input layer and hidden layer, right? So the function is to carry values assigned from one layer to another layer. That's the function of the edges or links that's connected between input every layers and every nodes, right? So and Yes, we have seen about nodes and edges. Next, to specify about layers, there are mostly we will be having input layer or hidden layer. Hidden layer may consist of one or more or multiple layers within it, and output layer. Okay, so yes. Next, we step into what are the concepts in new network. Okay, so yes. As we said before, the x here we can see that x1 uh, is x1 is a value passed to the input node, and the node passes the value of x1 to the hidden node. Here we can see that blue circle, right? This circle is generally a hidden node. Okay, so this circle is responsible for any computation and learning complex patterns, right? And we can see that x1 carries w1, that is the weight which adds value to which gets multiplied by using dot product with x1, and it is passed through to the hidden layer, right? We also add bias to the hidden layer. So bias for each layer will have the same bias value. Okay, so these bias value will give you a non-zero number even if the input is zero. So yes, here we can see a partition in the circle. So the first partition means the z is equal to summation of wi xis. So here the mostly the function will be product dot product of weight and input, as well. If there is any bias provided, we will add to it finally. Okay. So this layer is actually known as affine transformation. Okay. Next, we have another partition called f of z, right? So this f of z is activation function. So first, what is an activation function? An activation function in a neural network makes the model to learn complex patterns by providing nonlinear functions. So mostly the activation function is nonlinear, right? The common nonlinear functions that we use for activation function here is sigmoid, tan h, and relu. Yes, the formula of tan h is actually e power x goes like e power x minus e power minus x whole divided by e power x plus e power minus x. Here we'll be using it in code, right? So the inbuilt function is tan h of x. And relu is yes, if the value is greater than one, if the value is positive, I mean greater than a non-zero number, then the value will be x, what is the number that we provided, and if it is less than 0, that means negative, or even it's either it's negative or 0, the value will be 0. So that's the function here specified as max of 0 comma x. Okay, so these are the common functions that we use in rotation function. Actually, yes, one more thing to add. Here we have said that the function of a node is to receive an input, do the computation assigned, and to produce the output, right? So we start from the input layer, and we just pass the value of x1 to a hidden layer through this edge, and it is passed to every nodes in the hidden layers, each of the nodes in the hidden layers, and weight is multiplied to it, and if there is any bias provided, we add to it. Okay, so it will just pass through the hidden layer, and non-activation function like sigmoid function, even or relu function, or tanh function is performed, and then it is again passed to another the second layer of the hidden layer. Here again uh, non-complex the activation function is performed, so that it can have the ability to learn the more complex functions. So here this is the uh, this is the place where it is generally different from machine learning. So machine learning can't have the can't receive the can perform complex functions, but a neural network can. So here with the help of hidden layers, and again, if the computation is performed, it will be passed to output layer. Okay, so this process, starting from the input layer, the data is passed from input to hidden, then to activation function is performed, and then to output layers, right? So this process is known as forward passing. We pass the value from the input, and we apply it to output, right? So actually, in a data set, there will be a target value known as the output value. That is the actual output. What's that's being provided in a data set. So here we pass a value and perform some computations, and we obtain a output, right? So that output is known as predicted output. The error makes the gives us the variation between the predicted output and actual output. So our aim is to obtain a value that's minimum in error. The value of the error should be minimum, so that the network, we can say the network is, it's more efficient. So the efficiency of network is predicted by the minimization in errors. So it should not be exactly zero. It should be close to zero, right? So our function is to minimize the error. First, we have to do one iteration of just we have to pass the values, get an output, and we have to predict the error. So actual value minus actual output minus predicted output. So the error, uh, we apply an error, right? So we try to minimize it. So for the case of minimizing, we use a concept called backpropagation. So we just pass the value to backpropagation in order to adjust the weights of each edges, so that again we do in next iteration we'll get a value with less amount of error. So our goal is to minimize the error. That's what we do in a neural network. And it should, yes, as said before, it should not be exactly to zero. If it's exactly zero, then there is no use of making a model and implementing it. So if the value is if we have the error as zero, then the condition will be overfitting, in which the model exactly learns the data instead of learning the pattern, so that when you perform the model in a unseen data, there will be poor output. Okay, so yes, that's what the concept we can discuss with these input layer, hidden layer, and output layer. So yes, we start with the types of neural networks that's been mostly used now, like artificial neural network, convolutional neural network, and recurrent neural network. Starting from artificial neural network, let's start it by learning the concepts and implementing it day by day. So thank you.